Dilution was defined as the negative logarithm of hydrogen ion concentration, that is pH is equal to minus log of hydronium ion concentration. So, from equation 1 where we have got that pH is equal to log of hydronium ion concentration, reciprocal of hydronium ion concentration. From there, that is pH is equal to negative logarithm of hydronium ion concentration, we can get this equation, that is log of hydronium ion concentration is equal to negative pH. So, taking the anti-log both sides, we are getting the hydronium ion concentration is equal to 10 raised to power minus pH. Thus, the pH may be defined as negative power to which 10 must be raised to equal the hydrogen ion concentration. For neutral solution, as I have already derived that for neutral solution the hydronium ion concentration is equal to 1 into 10 raised to power minus 7 mole per liter at 298 Kelvin. So, let us calculate the pH value for this concentration. So, applying this formula, that is pH is equal to negative log of hydronium ion concentration is equal to negative log of 1 into 10 raised to power minus 7. So, solving this, that is taking the power into front, that is negative into negative 7 log of 10. So, answer is 7. So, I have derived that the pH of a neutral solution is taken to be 7. So, what is the pH of acidic basic solution which can be distinguished? So, acid and basic solution can be distinguished on the basis of pH. For neutral solution, the hydronium ion concentration is equal to 10 raised to minus 7 or the pH is equal to 7. For acidic solution, hydronium ion concentration is greater than 10 raised to power minus 7 or pH is less than 7. For basic solution, the hydronium ion concentration is less than 10 raised to power minus 7 or pH is greater than 7. So, for acidic, basic and neutral solution pH is 7, for acidic solution pH is less than 7 and for basic solution pH is greater than 7. So, for acidic solution, here I have clearly shown on this slide that pH is less than 7, basic solution pH is greater than 7, for neutral solution pH is equal to 7. So, what is the relationship between pH and pOH? pH is equal to minus log of hydronium ion concentration. So, pOH is equal to negative log of hydroxyl ion concentration. So, I have already derived the relationship, that is hydronium ion concentration into molar concentration of hydroxyl ion is equal to Kw, that is ionic product of water. And I have told you that ionic value of ionic product is 10 raised to power minus 14 at 298 Kelvin conditions. So, I have applied this equation here, that product of molar concentration of hydronium ion and product of molar concentration of hydroxyl ion is equal to 10 raised to power minus 14. So, taking log both sides, we are taking the log of hydronium ion concentration plus log of OH negative ion concentration is equal to the log of 10 raised to power minus 14. So, when we are taking the log, then what we are getting the next step, that log of hydronium ion plus log of hydroxyl ion is equal to 14. So, then we have to apply, we are just going to get the relationship between pH and pOH. So, how to get? On the left hand side, we are taking the negative log of hydronium ion because that is equal to pH. So, we are just changing the signs, that is negative log of hydronium ion, then negative log of OH negative ion is equal to 14. So, taking the negative common, and then we are getting with negative hydronium ion concentration is equal to pH and negative hydroxyl ion concentration is pOH. In the first two steps I have written this, that is pH is equal to negative log of hydronium ion concentration, pOH is negative log of hydroxyl ion concentration. So, pH plus pOH is equal to 14. So, we have got this relationship, which we were further going use this relationship in numericals. So, this is the pH scale. I have clearly indicated here that what is pH scale. It varies from 0 to 14, and hydronium ion concentration I have indicated, then hydroxyl ion concentration also I have indicated. So, for the acidic solution, the hydronium ion concentration is less than 10 raised to minus 7. For basic solution, it is greater than 10 raised to minus 11. So, neutral solution, it is equal to 10 raised to power minus 7. So, on the left hand side, there is increasing hydrogen ion concentration, and on right hand side, there is increasing hydroxide ion concentration. So, the pH of neutral solution is 7, and it is less than 7 for acidic solution, and for basic solution it is greater than 7. So, I have clearly distinguished the acidic, basic and neutral solution on the basis of pH. Now, I am going to discuss the numericals based on pH. Let us start with the first example. I have already discussed the different formulas which are used for the calculation of pH. So, first the simplest relationship between pH and the hydronium ion concentration was pH is equal to negative log of H positive ion concentration. So, what is the numerical? Let us read that. If an acid has hydronium ion concentration of 0.001 molar, then find out the pH. So, what are the steps for the solution is, first convert the number to exponential notation, find the log and then solve the pH equation. Hydronium ion concentration, that is H positive, is equal to 0.0001 molar. So, let us convert into exponential notation, that is 10 raised to power minus 4. Log of 10 raised to power minus 4 we have to take. So, that is equal to negative 4. Then applying this formula, that is equal to pH is equal to negative log of H positive ion concentration. So, negative log of 10 raised to power minus 4. How to solve with this logarithm? That is, take the power in front and take out the log of the base. So, taking the power in front, that is negative 4, then log of 10 is equal to 1. So, what is the answer for the pH of the solution having concentration 0.001 is equal to 4. So, in this way I have tried to solve this simplest example of pH by applying the formula, that is negative log of hydronium ion concentration. Second numerical is, if the base has an hydroxyl ion concentration of 0.001 molar, then find out the pH. First, find the pOH similar to that of finding pH, then subtract the pOH from 14. So, what we have to do? First of all, you just convert the hydroxyl ion concentration into exponential form, that is 0.001 is equal to 10 raised to power minus 3. Then I have also derived this relationship, then if pH is equal to minus log of hydronium ion concentration, then pOH will be equal to minus log of hydroxyl ion concentration. So, applying this formula, that is pOH is equal to negative log of OH negative ion concentration, putting the value, that is 10 raised to minus 3 in the formula, then finding out the log of negative log of 10 raised to power minus 3. How to solve this? Take the power in front and then take the log of base. Power is 3 and take it in front, that is negative 3, that will become plus, log of 10 will be equal to 1. So, answer is 3. Now we have to find out pH. I have already derived this relationship that pH plus pOH is equal to 14. So we can apply this formula, that is we have got pOH is 3. So pH plus pOH is equal to 14. So subtract the pOH from 14, then we will getting the value of pH, that is equal to 11. In this way, I have discussed the two types of problems where the concentration of hydroxyl ion and the concentration of hydronium ion is given to find out the pH. I hope you have understood the topic of pH, and you will find it easy to find out the pH of the solution. Let us take the brief review of the topic. What topics I have discussed here? I have discussed what is equilibrium, and then I have came to the point that what is the ionic equilibrium. So, what is equilibrium? This is the state of process where the concentration, temperature, pressure and of the reactant and product does not change with time. So, it is always maintained in closed vessels, and it is always attained in the case of weak electrolytes. Then I have discussed the ionic equilibrium, where ionic equilibrium is formed whenever the molecules they are ionized to form the two types of ions. Then concentration of ions increases and the ions they combine together to form molecules again. At that stage the ionic equilibrium is set up. Then I have explained the types of equilibrium. What are the types of equilibrium? That is physical equilibrium and chemical equilibrium. Then I have discussed the terms used in ionic equilibrium. I have discussed what is electrolyte and what are the types of electrolyte, that is strong electrolyte and weak electrolyte. Then I have discussed the Arrhenius theory of ionization, and there were the 6 postulates of Arrhenius theory. Then I have discussed the factors influencing the degree of ionization. So, what were the factors? They were dilution, temperature, nature of solute, nature of solvent and the presence of other substances. Then I have discussed the Ostwald dilution law, that is ionic equilibrium in aqueous solution, which I have derived this relationship, that is K is equal to C alpha square. So, in ionization of water topic, I have derived the relationship, that is ionic product of water, that is equal to Kw is equal to the product of the concentration of hydronium ion and the molar concentration of hydroxyl ion is equal to Kw. And its value is taken to be constant, that is 1 into 10 raised to power minus 14. Then I have explained the concept of pH, which is negative log of hydronium ion concentration. I hope you have enjoyed the session and try to understood the lecture. Thank you.